Okay, good morning. So let us start today's lesson. I will try to actually teach you two topics today. So one is actually polynomials. We have started refreshing our memories about what a polynomial is, and then I want to give you some more ideas about polynomials today and then move to the next lesson, which is also a very simple lesson. So we learned about the polynomials. So for example, if I write an expression like, for example, algebraic expression 2x to the 4 plus 5x to the 3 minus 2x plus square root of 2, this is a polynomial, yes, in one variable x. And then why this is a polynomial? Because these powers are non-negative integers, yes. So all the powers should be non-negative integers, otherwise this is not a polynomial. And these numbers sitting here are actually called the coefficients of this polynomial. For coefficients, we usually do not have any restrictions. You can choose whatever you like, yes? So that would be a polynomial in one variable x. Yeah, polynomials are also special kinds of functions, so we usually use the same notation for functions that we use, but because this is a polynomial, it's more natural to choose p. Usually the letters that are chosen for polynomials are p, q, r, and s, and something like that. So I would say that this is a polynomial p of x. What is very important to know about this polynomial is a terminology called the degree of the polynomial. So I would write deg for the degree, and then I can write the polynomial px in front. What is the meaning of the degree of the polynomial? Is the highest power that appears on the variable for the polynomial. So the variable of this polynomial is x. Here the power of x is actually 0. The power of x is 1, power is 3, power is 4. So it means that the highest value is 4. So we say that the degree of this polynomial is 4. Yes? So that is something very simple. Okay. And then this is also we learned in Math 2C, and we actually practice a lot. So polynomials, you can do arithmetic with polynomials, meaning that you can add them, you can subtract them, multiply them, raise them to some power, and divide them. Division is not part of your lesson. So, but any other operation, you need to be able to do them. So you need to be able to add them, subtract them, multiply them, and raise them to any power in principle. Yes? But division would be a lesson for Math 4. So if you continue there, you will learn how to divide polynomials by each other. Okay? So I don't know if really we want to go through this. For example, if I give you the polynomial px, let us keep it like this, and let me change it. Let me introduce you another polynomial. Yeah. So let me choose from the beginning. So let me call this polynomial px. Let me write 2x to the power of 3 plus 5x minus 1. And then let me write another polynomial qx. For example, I would write 2x to the power of 2 minus 1. So these are two polynomials. Let me make it minus 3x plus. So if I want to add these two polynomials, p of x plus q of x, so in principle, I should put a pair of brackets around the first one, and then plus a pair of brackets around the second one. Okay? But in principle, we don't need the pair of brackets here because the signs are positive, so I can remove them safely. So I remove them, it becomes 2x cubed plus 5x minus 1. Then I will have 2x squared minus 3x plus 1. And then what I have to do, you remember what we are supposed to do, yes? There are some terms that are called similar terms, the terms that have exactly the letter part identical. So here the letter part of it is x to the 3, but I do not have any other terms with x to the 3, so that is alone, yes? But when I go to 5x, I have 5x here and minus 3x here, they are similar. Why? because the letter part here is x, the letter part here is x, they are completely identical, so these are similar. So I can say that this one and that one are similar. Are there any other similar ones? Yes, here minus 1, actually the letter part is x to the 0, the letter part is also x to the 0, we haven't written it down, so these two are similar. And then we can start adding them or subtracting them correspondingly. So for example, I would write it as 2x to the 3, and then I will have 5x minus 3x, which is positive 2x, and then I will have minus 1 and 1 are cancelled, and then I am left with 2x squared. So this is the sum of px and qx. Yes? But of course, I myself prefer to arrange them in descending order of the powers. Yes? Of course, if you write it like this, that's completely acceptable. But if I want to write it, I myself prefer to write it from the highest power to the lowest power. Yes? So then it becomes 2x cubed plus 2x squared plus 2x. This is not compulsory, but it's much better to be organized when you are doing mathematics. Okay? So now one question. If I ask you what is the degree of p of x, what is the answer?
3.
Yes. What is the degree of q of x?
2.
It is 2. When I add it, I get a new polynomial. If I ask you what is the degree of this new polynomial, what would be your answer?
3.
It's again 3. So now what is the general rule behind that? So my question is this. My question is that if I give you two polynomials, px and qx, okay, if I add these two polynomials, it becomes a new polynomial, and if I want to find the degree of this polynomial, do you think there is a nice relation between the degree of the sum and the degree of each one of those polynomials individually? Yes?
Maybe it's just the degree of the highest exponents.
So how many of you agree with him? Yes? Is it right?
Yep.
Yes? What's wrong?
Well,
Yes, because it might happen that we are unlucky, something happens.
Mhm.
So what Gustav is saying, and some of you confirm that, you are saying that we take the degree of p of x, yes, and then we take the degree of q of x individually. They become two numbers, and then I calculate the maximum of these two numbers. By the way, this is the symbol we use, and that's very standard. So we put curly brackets around two numbers, and then I put the max or the mean, meaning the maximum of those elements or the minimum of those elements correspondingly. Yes? So here, so what Gustav said is actually this, which is correct for this case. So if I ask you, let me use that formula for this case. I want to calculate the maximum of the degree of this one. What is the degree of p of x? It's 3. What is the degree of qx? Is 2. So what is the maximum of these two numbers? Definitely it is 3. And if you look here, what is the degree of the sum? It's 3, so that's okay in this case. But there is one exception sometimes. Can you imagine that? Which, yes, Robert?
Let's say there. No, I can't explain it.
Yes, Aaron?
Okay, like maybe if say q had minus 2x3 after it, and then if you calculated it, there would be no 2x3, and then the highest would be 2x squared.
The highest will cancel, yes? So, yes, that's correct. So assume that instead of having this qx, let me write a qx with a capital letter to just differentiate these two. So assume that instead of having 2x squared, I have minus 2x to the 3 minus 3x plus 1. So I do not touch these two. I'm just changing the first term to minus 2x cubed. And now I am asking the same question. So you agree that if I add them, what will happen? This 2x cubed and that minus 2x cubed are cancelled. So if I ask you, can you just imagine, if I ask you what is the degree of p of x plus this q of x, you can imagine it in your head. What is that? So if you want, I can add them here. So p of x plus the capital Q of x is equal to. So this one and that one are cancelled, but 5x minus 3x is 2x, and then minus 1 plus 1 is 0. So the sum of these two polynomials is 2x. And if I ask you what the degree of this is, you will answer the degree is 1. Yes? So the degree of this is 1. But if I ask you to calculate the maximum of the degree of p of x and degree of q of x, oh sorry, capital Q of x, what would be your answer? This becomes the maximum. Degree of this is again 3. Degree of this one is also 3. So what is the maximum now? Everyone, what's the maximum? Maximum of 3 and 3?
3.
It's 3, yes? So you see that these two numbers are not equal. So if I say that this is equal, it might happen that this is not the case. Yes, is that understandable? So the rule is not that equal. Can you just change this so that it is correct? So we saw that it's not always equal. Of course, sometimes it is equal, but sometimes it is, yes? It should be lower, yes? Sometimes it is lower. Can it be higher? Can you have two polynomials so that when you add them, the degree of the new polynomial is higher than the maximum degree? This cannot happen, yes? So if you are unfortunate, the degree would be smaller. So the correct form is not equal, is less than or equal. Yes? So be careful. That's one of the formulas in the book. So the degree of the sum of two polynomials sometimes is equal to the max degree, but sometimes it is less than the max degree. So this is something that you need to know. What do you think about subtraction? So let me just do the subtraction here. So if I ask you calculate p of x minus q of x, so what you need to do, you need to write 2x to the power of 3 plus 5x minus 1, and then you have minus, instead of qx, you have 2x squared minus 3x plus 1. So do you remember, this is something that sometimes if you are careless, you make mistake, but you are now grown up. So promise that you will not make this mistake anymore. And what that mistake is, do you remember? I emphasize in Math 2C a lot. Yes?
You mean forgetting to invert the signs?
Yes. So usually people take this one and put the minus sign for the first one, which is not correct. You have to multiply this minus sign here, 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 and in all the terms. Yes? So that you need to promise yourself and promise me that you will not make that mistake. Okay? So here I remove these pair of brackets without any problems because there is no sign written behind that. It means that that sign is a positive sign. So I just remove this pair of brackets. But here I multiply this by negative sign, so it becomes negative 2x squared. If you just write minus 3x, it would be wrong because minus is also applied here. It becomes positive 3x, and this minus will be applied here. It becomes negative 1. So that is the only crucial part when you want to subtract two polynomials. Remember from now on forever, so that when you want to multiply the negative sign, you have to multiply it everywhere. And now the next is the same. So it doesn't matter. I'm just finding the similar terms. No similar term here. So let me just write it down. I have again this one and that one are similar. Minus 2x squared, no similars. So let me just write it here. And then 5x and positive 3x becomes positive 8x. So I put positive 8x. And then minus 1 and minus 1 is minus 2. So that would be my polynomial. Now if I ask you what is the degree of this resultant polynomial, it's again 3, yes? Okay, so, and then let me just calculate p of x and minus q of x. So p of x is this polynomial, q of x is this polynomial, so I would write 2x to the power of 3 plus 5x minus 1, and then what I do, I would write minus this polynomial, which is minus 2x cubed minus 3x plus 1. And then what happens, I just remove the pair of brackets here, so it becomes 2x cubed plus 5x minus 1. I multiply the negative sign in, it becomes positive 2x cubed, positive 3x minus 1. And then they add actually together. So it becomes how much? 4x to the power of 3. And 5x plus 3x is 8x. And then I have minus 2. Again, if I ask you what is the degree in this case, what that degree is, do you hear sound or something? Yes or no?
What's the sound over there? But
Yeah.
what are you?
I was
referring
thinking
to?
that probably there is some kind of noise coming from the loudspeaker. No, you don't hear that. Okay. Okay, so 4x to the power of 3 plus x, 8x minus 2. So the degree is 3. So can you tell me what happens for the degree of subtraction for the difference of these two polynomials? Do you think the same formula is still valid? So if it was positive, if I am adding two polynomials, we realize that this relation holds. What do you think? If I change this addition to subtraction, do you think the same relation will work here again?
Yes.
Yes or no?
Yes.
Yeah, yes. For example, here, if I have chosen this to be positive, what would happen? Then after this being multiplied, it becomes negative and they will cancel out. So be careful about this relation. So this is one of the relations in the book. Now let us continue and try to go to the other operations. So addition, subtraction, these are the first two arithmetic operations that we learn even in primary school for numbers. Now what is coming next? Multiplication. So let us just do multiplication and see how it goes. So these are all reviews except that this one is more or less new, writing it formally. I don't remember if I have already talked about the degree of a polynomial for you in Math 2C, but here this is formally introduced. So this is why we're going through it. And by the way, why I cannot add these two? This is, of course, I have already talked about these things in Math 2C, but might be you have forgotten. For example, if I ask you add 2x plus 3x, what can you write it? You can write 5x. But why is that?
They're the same exponent.
Yes, of course, that is the rule coming after that. So I just gave you a rule of thumb. Whenever you see that the letters are identical, you can just add the coefficients. But why this is what is the main principle of arithmetic behind that we can do this? By the way, let me just a little bit go back. In algebra, what is x in algebra? What do we mean by an x? What's the name of an x?
Variable.
It is representing a number, but we call it a variable. Yes, it's a variable, but every variable in algebra is representing a number. So this is why we can multiply 2 by x, because x is an English alphabet. So you see, it's very strange. If you just assume that a primary student just learned how to add two numbers, and then suddenly you tell them, okay, add x plus y. This is ridiculous, yes, because she or he knows about these as English alphabets, and they don't know about anything of adding alphabets, yes? Adding makes sense if you're adding numbers. So even the same is true here in algebra. When I say x plus y is something meaningful in algebra, it means that x is representing, we don't know what x is representing, but we know that x is sitting instead of a number and y is sitting instead of a number, yes? So this is why this operation in algebra makes sense. Otherwise we cannot add letters x and y together, yes? Is that understandable? So that's the same story. When I say 2 times x, x is a letter, but in algebra it is sitting instead of a number. So this operation makes sense because both of them are numbers. This is a constant number. I can see the value. If you ask me how much is this, I would say it's 2. But if you say how much is x, I would say I don't know yet. Unless you assign a number to it, then I will say that the value of x is that number. But before assigning a number to that variable, it's just a variable, but it's a number. Understandable? Okay. So why we can do that? It's a very important property. So you know that if I have 3 numbers, so 2 times 3, so let me just write it, 2 times 5 plus 3 times 5. Yes? So what you can do, you can actually factor 5 out. You can write 2 plus 3 times 5. There is a name for this property for numbers, and that is called distributive law. So you can distribute a product, a multiplication over addition. So you can distribute it. So if I have the sum of two numbers, I want to multiply 5 inside this pair of brackets. I can do it, I have to do it in this way. I have to multiply it by the first one, I have to multiply it by the second one. So that is called distributive law of numbers. That is possible. Yes? So you need to understand that this is important. Of course, when I am dealing with numbers, if I ask you to calculate this, might be you do not choose this alternative, might be you choose 2 plus 3, which is 5, and then multiply 5 by 5, and then you immediately answer 25. But if you do this, it becomes 10, and 15, it becomes 25. So usually people prefer to do it in this way than doing it in this way. But if I do not have numbers, fixed numbers, this one is the only one that I can do. For example, if I ask you to multiply 2 by x plus y, you cannot say that I add them, I get a number, I multiply that number by 2y, because the numbers are not known to me yet. Is that understandable? So if you want to follow, if you want to write something in front of it, technically it is possible to add them first and multiply it by 2, but we cannot do that here because I don't know the values of x and y. But if I want to do something in front of it, I can just distribute this multiplication over addition and saying that this becomes 2x plus 2y. Yes? So this is the difference. In algebra, technically both of them are correct, but in algebra, if I want to write something in front of it, I have to use the distributive law. Yes? Is that clear?
Yeah.
Okay, now, so why this is correct? Because you know that 5x is, instead of 5, I can write 2 plus 3, and then I have multiplied by x, so I can distribute it. So 2 times x, and then plus 3 times x. So that's exactly why 2x plus 3x is equal to 5x. But, if you remember, if I ask you to write something in front of this one, what can you write? Now, so, not factoring things, okay? So can I add them? So by the rule of thumb, you say that no, the latter part of the first term is x, the latter part of the second one is x squared. They are not identical, so I will leave it alone, just like that. But why? What is the deeper reason why we don't do that? You want to say something?
Right. I was thinking you could take x out.
That's a factorization. That will work. So you can factor it out, and then if it becomes 3x. But again, this is distributive law, yes? Why? Because if I multiply it back, I get the same thing. But if I want to add them, 2x plus 3x, I could write 5x, but I cannot simplify it in one term here. Yes? Why is that?
Well, x and x squared aren't the same values. They aren't the same number, and so you can't just add them.
That's a good reason, because you are saying that if I give you, I have two boxes, and I have 3 more of the same box. How many boxes do I have? It is 5 boxes, yes? So that's as simple as that. So it becomes 5 boxes. So in this case, this is playing the role of your box. So I have 2 boxes, and I have 3 more boxes of the same thing, so I have 5 boxes. Yes? But here, if I call this one box, this one I should call something else, because that is not exactly the same thing. Yes, it is something to power 2. So I don't know. If I have this as a box, I have 2 boxes, and I have 3 circles. How many things I have? I have again 2 boxes and 3 circles. I cannot add them and say I have 5 circles, I have 5 boxes, I have 5 mixture of them. No. I have to write them like this. I cannot continue. Another reason for that is the priority of operations. So here, if I give you to calculate this, no, let me just keep it exactly like this with this number 5 here, and let it be 3 to 5 to the power of 2. If I ask you to take your calculator. Of course, this is very simple. How do you calculate this? How many operations are involved here? I have two multiplications here, one addition and one power. So I have these mixture of operations. So where we start from? Yes. Yes, yeah, Abdul Manan.
You start with the power to the power 2, then you do the multiplication 3 times 25, and 5 times 2, and then you multiply.
Yes, and then add. So, but this is very, by the way, so you usually memorize these priorities, but you really don't need to memorize. Because, can I start from this?
No.
You don't need to memorize, no. Why? Because when I ask you to add two numbers, what is my duty? My duty is to give you two numbers and then ask you to add them. If I don't give you the numbers, how should I ask you to add them? Yes? Now here, if I am asking you adding two numbers, so I have to give them to you first. Yes? So it's natural, you don't need to memorize. So you need to know 2 times 5. So it means that which one has the priority. You have to do this one to understand what the number is, which is 10.
16.
And then you have to calculate this one. Now I want to calculate 3 times 5 to the power of 2. I have a multiplication and I have a power. Which one has the priority?
Power.
Yes? The power. Why? Exactly the same story. If I ask you to multiply two numbers, first of all, I have to give you the numbers, then I ask you to multiply them, yes? So if you want to multiply them, you need to know the numbers. You don't have any problems with 3, that's 3, but you have some problems with 5 to the power of 2, which is 25. So it means that automatically you calculate 25 here, and then multiply it by 3, it becomes 75, and then add them. Yes? So that's the same story here. You see, if I have 2x plus 3x squared, here I have a problem. Because you learned, if I give you this expression and ask you find the number, assume that you want to find the number, what you have to do first? You have to calculate this first. You have to calculate this first, and then add them together. Before calculating this and calculating that, you cannot go further. But can you calculate 2x? No, because you don't know x. Can you calculate this? No, because you don't know x. So this is why at the level of algebra, you have to leave it alone. You cannot continue. Is that understandable? Yes or no? So this way of thinking is important. But of course, after understanding this, a rule of thumb is that x and x squared are not identical, so leave it alone. But if someone asks you what is the deeper reason behind that, you should be able to explain that if you like mathematics. Okay, now let me just go and try to review a little bit about the polynomial multiplications, yes? So, for example, let me just give you two polynomials, p of x. Let me make it 2x squared minus 3x plus 1, and then let me make q of x to the, let us, 3x to the 4. Now let me make it easier, for example. So minus 3x to the 2 plus 5x negative 2. Yeah, let us make it a little bit longer here. So I want to multiply them. So I want to multiply p of x by q of x. Okay, so let me just write it once more in front of my eyes so that I don't get confused. And then I have minus 3x squared plus 5x minus 2. Because I am counting a little bit about your knowledge from previous lesson, so this is why I didn't start it from the simplest possible example, but I don't think it's hard. So what is the important thing? Do you remember if I want to multiply a polynomial by another polynomial, what should I do? Let me review a little bit. If I ask you just multiply a by b plus c, that is just the distributive law. So what you do, you just multiply a by b, you multiply a by c and add them. So that is the fundamental law, that numbers following that law. Yes? Now, what happens if I have more than one term and another term? So this term, this distributive law, involves three numbers, a, b, and c. So whenever you want to use distributive law, you have to have three numbers. But what happens if I have more than three numbers? A plus b multiplied by c plus d. How many numbers are involved here? 4. But I can consider this package as one single number. And this is a very important technique that you need to learn. So now if I look at this as one single number, then how many numbers are involved?
3.
Then 3. Can I use distributive law for this case? Yes, because distributive law is for 3 numbers, and here I have 3 numbers. So then what happens? I take the capital A, multiply it by C, it becomes capital A multiplied by C, plus I take capital A multiplied by D, it becomes capital A multiplied by D. Okay, then let us check it. So let me take this and put A plus B instead, because that A, capital A, was sitting instead of A plus B. So let me just write A plus B multiplied by C, and the same story here, A plus B multiplied by D. But can I use distributive law here?
Yes.
Yes, because how many numbers are involved again?
3.
3. So I can use that. I multiply it, it becomes A dot C plus B dot C. And I use distributive law here, again, yes, so it becomes A dot B plus B dot D. Is that understandable? So it means that the real distributive law is a relation between 3 numbers, but it doesn't mean that I have to always have 3 numbers. I can have more than 3 numbers by this trick. Yes? And now we don't do this anymore. We learn that and then we do it quickly. So let me check what happens. A is being multiplied by C. Yes or no?
Yes.
Yes, we have it here. A is being multiplied by D. Yes or no?
Yes.
Yes, we have it here. This is multiplied by that. Yes, we have it here. And then finally this is multiplied by that, we have it here. Yes? So this is why, even if I have more, I think you can imagine, even if you have more terms, you can continue this trick for all of them and get your final answer. Is that right? This is the understanding of the problem, but we don't explain this all the time. I want you to understand that there is one important property of numbers that I am using over and over again. Yes, to be able to solve this problem. Okay? Now, if I give you this in the exam, you really don't need to explain this, but you need to use the rule that you learned. That is up to you. If you want to know everything, to be able to explain to your friend, so this is the way that you have to explain. But let me just do it here. So what should I do? I myself take this one, the first one, and I multiply it by every single term from the second polynomial. Yes, so what happens? It becomes minus 6x to the 4 plus 10x to the 3 minus 4x squared. Yes? Everybody happy with that? So I am using one rule of powers. What that rule is? Can you mention which rule I am using here? So you see, when I multiplied that by that, I multiplied 2 by minus 3, which is minus 6. And then I multiplied x squared by x squared. I write x to the 4. So which rule I am using? Yes?
X to the power of 2 is exact times x to the power of 2 is the exact same as x to the power of 2 plus 2.
Yes. So this is the main rule. A to the m multiplied by a to the n in general is a to the power of m plus n. So if I am multiplying two exponentials with the same base, I write the same base and I add the exponents. Yes? So that's the same story here. So 2 multiplied by minus 3 is this one, and x squared multiplied by x squared, as Hussein actually described, it's x to the power, according to that rule, 2 plus 2, but 2 plus 2 has a better name, and that is x to the 4. Another crucial thing is here. What is important? Why do you think I multiplied 2 by minus 3? Could I multiply 2 by x squared? Because what I am doing, I am telling you to multiply this. Yes? Let me ask you, what is the operation between these two?
Multiplication.
Multiplication. The operation between these two? Multiplication. If I give you 4 numbers to multiply, for example, 2 times 3 times 4 times 5. If I ask you to multiply, of course, you might start from here. 2 times 3 is 6. 6 times 4, 24 times 5 is what? 120. But in principle, even though you might don't do this, but if you want, you can multiply this by that. You can multiply this by that and then multiply the answers. 2 times 5 is 10, 3 times 4 is 12, 10 times 12 is 120. But why I told you multiply this by that and this by this? Why did I give you this order, even though in principle you don't need to respect the order? Yes?
But with that order 2 times 3 times 4 times 5, isn't there a rule that says that you need to do it from the left to right?
No. This is very important to remember. By the way, don't get confused. This is not distribution law, yes? This is called associativity and commutativity. Forget about the names. So, but you have how many 2's you have? You have 1, 2. You can choose. You want to multiply it here? Do you want to multiply it there? Do you want to multiply it there? That's up to you. Okay? So if you want to do it, of course, if I want to do it, by the way, if I want to do it, I do it in this way. Why? Because 2 times 5 is 10, multiplying numbers by 10 is easier. Yes? So you see, 3 times 4, everyone knows 12, and this is 10, so you immediately get 120. In the other case, I need to multiply 5, I need to multiply 6, 24 by 5, which is harder. Yes? But what I'm telling you here, without telling you, I told you that multiply 2 by minus 3 and multiply x squared by x squared. Why is that? Because this is the only way that you can write it more compactly. If I tell you, if you write this, do you agree this is okay or not? This is a little bit. So here I am multiplying this by this x squared, and I am multiplying this by that squared. Do you think this equality is true or false?
True.
It's true, but useless.
Yeah.
Why? Because my goal in algebra is to write expressions more compactly. If I do this, this is true, but it is not more compact than that one. So what is the benefit of that? But if I multiply, as I told you, if I multiply 2 by minus 3, instead of writing it as 2 minus 3, I have a more compact name for this. What is that? Minus 6. So this is why you don't think you have to, but it is completely reasonable to do this because your goal is to write it more compactly. Yes or no? Yes or no? Yes. Okay. Now, let us just continue. So, I took the first term and I multiplied in every single term of the second one, and when it is finished, of course you can do it randomly, but I really do not recommend you to do that. You need to be organized. Okay, then I will go to this one with its sign. I take this one, multiply it here, here, and there. So tell me, minus 3x times minus 3x squared is?
9x3.
Positive 9x3. And this one multiplied by that one is?
Negative
15x
squared.
squared. The next one?
6x.
Positive 6x. I am done with that. And then after this is done, I go to the last term, take it and multiply it to every term. But of course, this is very trivial. 1 multiplied by everything, by anything, it would be the same thing. So it becomes minus 3x squared plus 5x minus 2. If you stop here, your multiplication is finally finished, but I will deduct you some points from this. You will be deducted. Why? Because you have to simplify, even if it is not mentioned in the problem. So when I say expand, this is, by the way, expansion, or if I ask you to do this multiplication, if you stop here, your multiplication is completely intact, but it is not complete because automatically you have to simplify, even if this is not mentioned in the problem, yes? So what should I do? Do I have any similar term for minus 6x squared? No. So let me just write it. I prefer, I told you, I want to be organized in my writing, so I would prefer to write from the highest power to the lowest power. Okay, is there something similar to 10x cubed?
Yes. 9x.
Yes. And how much would it be? 19. Okay? So that's up to you. So for example, you can just write something behind that, so it means that I considered them. Okay, how many terms are similar to this? I have 3. Yes, this one, and that one. Yes, 2 more. So how much is that? Minus 4x squared minus 15x squared is so far minus 19x squared minus 3x squared minus 22x squared. Yes? So this is also considered. And I have 6x and 5x. So what is that? 11x
minus 2.
and minus 2. Am I right?
Yes.
So this would be the product. And now the same question here. So the same question about degrees. Okay? So now what do you think would be the degree would be? So I want to write something which is new. Formally it was not mentioned in Math 2C. It's mentioned in your book now. Okay, so what is the degree, or what is your guess about this degree? P of x multiplied by Q of x. Yes, Rocco?
Would it be the degree of the first one plus the degree of the second one?
Yeah, this is reasonable, isn't it? So if I ask you what is the degree here, what is that? 2. What's the degree there? It's 2. Because the highest term will be multiplied by the highest term. Forget about the other terms. Other terms have lower values for the exponent, but the highest value is definitely 6x to the 4, and this always happens. This is not something that it's possible to be cancelled out. Yes?
So we use the AM times AN rule when deciding the degree.
Yes, that's exactly coming from that rule.
Yeah.
So this becomes exactly as Rocco mentioned, so this becomes the degree of P of x plus the degree of Q of x. So that is extremely important, yes? So this is a little bit uncomfortable rule because it is not always equal. It's less than or sometimes equal. But this is a very good rule. If I want to ask you what is the degree of the product of two polynomials, that is the sum of the degrees of each polynomial individual. Yes? Okay. What do you think? If I have more than two polynomials, then what will happen? So, of course, this is not a mathematical proof, but this is so simple and trivial, so we just motivated you by this simple example. I could have mentioned, so you see that if it was 2 to the power of x3, and this was the same thing, of course, when I multiply, that would be totally different polynomial at the end. But one thing is clear, the highest power will come when I multiply the highest power of this by the highest power of that. Yes? And there is no risk of cancellation. Do you agree? That is the problem. In addition and subtraction, there is a risk that the highest degree somehow will cancel out if you are unlucky. But do you think that there is a risk for multiplication somehow the highest degree in the product to be cancelled out? No. No. Yes? Because when you take the highest power here and multiply the highest power here, you get something different from when you multiply this by that. Because here, if you get x to the 4, it is not possible to get x to the 4 from the next term. Because at least the next term has a lower x. Yes? So the highest value and the highest value, you add them, it becomes the degree of the product. Okay, now let me give you another example. If I give you 3 polynomials, so let me just, if I ask you to multiply these 3 polynomials, so what you need to do? Whenever you forget something, assume that you want to multiply 3 numbers. What is the rule of multiplying 3 numbers? That rule exactly will apply here because algebra is just about numbers, even though we are using letters. Yes, Aaron?
Well, first you do 2 times 3 and then that times 4. So for that one.
So you say that I will multiply the first 2. What I get, I multiply by the third one. Yes?
Yes.
Of course, if you want to, you can multiply this by the last one and you get the answer you multiply, or you can multiply these 2. It doesn't matter. So when it doesn't matter, I don't bother to just multiply this by that. I will go in order. So, but be careful. Do not multiply this here and multiply this there. You have to multiply, for example, this one by that one. You get an answer and keep that answer and multiply it by this one and simplify everything. That would be the final. So if I have more than 3 polynomials, 4 polynomials, for example, in 4 polynomials, you can do it one by one, or you can group them into multiply the first pair, multiply the second pair, and then multiply the answers. So that's very simple. Is that understandable?
Yes.
Yes? Okay, so if I want to do it here, what should I do? I start multiplying this, x by x, it becomes x squared. The way that you write is very important. X times 2, it becomes 2x, and then I have 1 times x, which is x, 1 times 2 is 2. Be careful, some of you are in hurry and lazy, but if you put equality, you need to pay attention what the meaning of equality in mathematics is. Equality means equality, so you cannot just jump to the next part of the page and say put equality. You have to be patient, write this, and you have to copy and paste this one. This is the correct way of writing. You shouldn't be in a hurry. When you put equality, you have to write it in this way. Yes? Do you have questions?
No, you should also, you don't need to, but it's more efficient if you then simplify inside the bracket.
Yes,
itself.
that's exactly the words that I wanted to mention. Of course, you can start multiplying right away, but how many terms will be involved? How many terms you see in this form? 4 terms. How many terms there? 2. So if 4 times 2 is 8, so you need to do it 8 times. You will have 8 terms. But if I simplify this, I will get 3 terms here, 2 terms there, it becomes 6 terms. So my preference is always to simplify and then proceed. Even though technically both of them are equivalent, but for our brain, because if I want to do it with hand, not with the computer, it's always better to simplify and then continue. Okay, so I would write the simplified version of that. Of course, I can just continue. It becomes x squared plus 3x plus 2. And then I multiply it by that. I have to do this multiplication once more. This is the way that you have to write it in the exam properly. This multiplied by that. By the way, before calculating, what's your prediction about the degree at the end?
3.
It's 3, yes? Because the degree of this is 1, the degree of this is 1, this is 1, so I add 1, 1, 1 according to this rule, so the degree would be 3. So let us check. X squared times 2x is 2x cubed, 2x squared times that is minus 3x squared, this multiplied by that is 6x squared, this multiplied by that is 9x plus 4x minus 6. Am I right? Yeah, please tell me if I made some mistakes. So 2x cubed is alone, this one and that one is 3x squared, this one and that one is minus 5x, and that one is minus 6. So as we predicted, the degree of this product is 3. Yes or no?
Yeah.
So, but powers are also important technically, but it's not a big deal. If I ask you 5 to the power of 2, how do you calculate this? So what you need to know is to know how to multiply, because that is just a short way of writing this product. Yes? So you need to multiply this by itself 2 times. So if I ask you for example, what is the answer to this? Of course, you have already learned the squaring rule, but forget about that rule for the time being. I want to, let me make it negative 3, and then I put a power of 2 up there. Of course, in Math 2C, we learned identities, algebraic identities, but forget about that. Assume that you don't know that. If you want to expand this, what I am supposed to do, I know that power 2 means multiplying this expression by itself. Yes? And then, so powers are not something new. It's just a product. Yes, the multiplication. So what happens, this one and that one is 4x squared, this one and that one is minus 6x, and then I have positive 9. And then it becomes 4x squared minus 12x plus 9. Yes? So for example, if I give you the same thing, and I ask you to calculate this to power 3, what can you do? You can write it 3 times and multiply them together. Yes, according to the rule that we had before. So, for example, you can, of course, because I have already calculated that, I can write it as this. Yes? That's also acceptable. Because power of 3 means multiplying it 3 times. So, but I have already done it 2 times, so I don't need to start everything from scratch. But if it was not given in the exam, so you have to write it 3 times and multiply it using the rule for 3 times. Yes? Is that understandable? Yes. Now, can you tell me what would be a relation for this? I give you a polynomial. I give you a polynomial p of x, I give you a natural number, I ask you to raise it to power n, and then I ask you what is the degree of this combination. So what would be the degree? So I am asking you if you, yes?
Wouldn't the degree be n?
No. N?
That's the exponent, yeah.
No. Now let me, for example, let me tell you this. X to the power of 3 plus 1 to the power of 2. What would be the degree at the end after expansion? This means x to the 3 plus 1.
6.
Yes. Because I told you that for the product, I have to add the degrees together.
Yeah.
Yes. So if I have a polynomial of degree 3 and I want to raise it to power 2, it means that I have to multiply 2 times. So the degree of this one will be added to the degree of this one according to this rule. So it becomes 3 plus 3, which becomes 6.
Yeah, but here the degree on px is 1, right?
No. I'm just
1
talking
times
in
n
general.
is just n.
No, I'm just talking in general. Not this p. P of x. I don't know the degree of p of x. So what should I write as a formula in front? Yes?
Wouldn't it be the degree of p of x times n?
Yes? So it should be n multiplied by the degree of p of x. Yes? So these are important rules. Remember them. For example, can you tell me what is the degree of this expression? If I ask you what is the degree of this expression, what's the degree of this? Without calculation. By the way, calculating this is really tedious. Why? How many terms will be involved here? No, 2 terms. I multiplied 5 times. It becomes 2 to the power of 5 terms, which is 32 terms. And then I multiplied by this, it becomes 64 terms. Okay? Yeah. So if I want to expand this, there are 64 terms that I have to simplify them, which is tedious, yes? But for finding the degree, which most of the time would be necessary, especially when we talk about limits, calculating limits of functions, so you should be able to immediately tell me what the degree is without any expansion. Yes, Gustav?
I was thinking that is 25, but I do believe I'm wrong.
Yeah, 30.
17?
30?
No. 17? Who said 17?
17.
17 is correct.
Okay.
Why? Because the degree of this one is 2. The degree of this one is how much? The degree of this one is 2. The degree of this one, according to this new rule, is how much?
It's 15.
Is 15. But now I am multiplying these two, so the degrees of multiplication would be the sum of the degrees.
Yeah.
Yes? So the degree of this one was 2, the degree of this one was 15. I am multiplying them, so the degree would be 17.
Okay.
Yes? So this is something that you need to learn, actually, to calculate the degree of these kinds of polynomials without having a big trouble. So let me just give you another example. So what would be the degree of 5x to the power of 3 multiplied by x2 plus 1 to the power of 5 plus x to the power of 3 plus 2 multiplied by (10 plus 2x plus 1. Yes. So let me make this one negative. So what would be the degree of this combination? I am raising this to power 5, I am multiplying it by this one, I am multiplying these two, then I am adding all these.
0.
No.
No, I'm kidding.
So this, you should be good, you should be quick and finding these degrees. What the degree is?
13.
13, yes. Why is that?
first one power 5, it's gonna be 10, and then multiply 3, 13.
Third, you agree? So this, if I ask you what's the degree, it's 10. What's the degree? It's 3. If you add them, it becomes 13. So the degree of this part is 13. The degree of this part is 30. But be careful, I am adding these two polynomials, which I have to be careful. Because sometimes it is not equal, it is smaller than. Is it one of those cases that it would be smaller than 13 or it would be 13? Because this is 13, this is 13. What is the maximum of between 13 and 13? It's 13. But you need to be careful because you see that sometimes it is not equal to the maximum. It is smaller than the maximum. But do you think the smaller relation happens in this case?
No.
Why not?
Because we have 5 times x or
Yes, yes. So what would be the coefficient of the highest power here?
5.
5. What would be the highest power here? Highest coefficient? Minus 1. Yes, is that understandable? You see, when it is possible that equality doesn't happen and a smaller than happens. When the highest powers are somehow cancelling each other. And when they cancel each other, if the coefficients are opposite. Okay? If I ask you, can you give me all the coefficients in your head? I would say no. But if you tell me, can you give me the coefficient of the highest degree? I would say yes. It is not hard to imagine. This to the power of 5 means writing this 5 times and multiplying it together. Can you tell me what it would, one term would be x to the power of 10. What would be the coefficient of x to the power of 10? Imagine it. You don't need to calculate.
1.
1, yes? Because when x to the power of 10 happens, when you choose x2 from each pair of brackets, yes, let me just write it for you. x2 plus 1 to the power of 5 is x to the power of 2 plus 1, 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 once more, yes? So that is 5 times. So it is clear, if you ask me, do you know the answer? I would say no, but if you ask me, do you know the coefficient that will sit here? I would say yes. Do you agree? Because if 1x squared and 1x squared will be multiplied, it becomes x to the power of 4. Of course, I have a lot of other terms. I don't care about them. But when I want to go to here, I have x to the power of 4, which will be multiplied by x to the power of 2, which becomes x to the power of 6. I have also a lot of more terms. But again, I will multiply the highest powers. So the highest power that appear in this expansion is x to the 10. Yes? Yes? And then what is the coefficient in this question mark? There is no reason that this question mark is something except an 1. Yes? Because this coefficient is 1, 1, 1, 1, and 1. When I multiply them, it becomes 1. Yes, questions?
How could we counter if it was if the coefficients of x3 was 1 instead of 5?
No, if that was this one you mean,
Yes.
in that case it is not that easy.
Yeah.
Because the leading powers will cancel out. We don't know if the next leading power also will be cancelled out unless you sit down and see that this is not the case or this is the case. So this is why I intentionally put a number here. Okay? So so that's a very important question. Benjamin, yes? So Benjamin is asking if there was no 5. Answering this question was not that easy because what is the coefficient of highest power? What is the highest power? 10 plus 3, 13. What would be the coefficient of the highest power? It would be 1. Because if this is 1, the highest power, the coefficient of the highest power is 1. Is that understandable for everyone? Yes or no?
Yep.
No.
Okay. No?
No.
So why not? Because you're multiplying things.
No, you said the coefficient is 1, but it's 5, so I'm just confused.
No, I'm saying that if it was 1.
Okay.
If it was 1, the coefficient would be 1 at the end.
Then I understand.
Yes? And then the unfortunate thing is that what would be the highest coefficient? What would be the coefficient of the highest power here? Negative 1. So definitely they will cancel out. Okay? Is that right?
Yes.
So when it is cancelled out, then we are doubtful what would be the next leading term. So this is why we face this less than relation, which is not valid. But in this case, you don't need to be worried. The highest power here is x to the power of 13, and its coefficient is 5. The highest power here is x to the 13, and the coefficient is -1. They will not cancel out. I will have some x to the power of 13 left, and that's the highest one. So the degree would be 13. Yes?
But we can ask about the formula, degree and px to the power of n.
Yes?
What if n was negative?
No. I'm not talking about negative powers. Because why we don't talk about negative powers?
Because negative powers means just 1 over.
And this is not a polynomial anymore.
No.
Yes, so I only talk about degree of polynomials, not algebraic expressions. So if I give you this, and I tell you what is the degree of this, that is my mistake. I'm not allowed to ask you what's the degree of this, because that's not a polynomial. Degree only makes sense for polynomials. Yes?
Is it the same thing with fractions? If it was 1 over n,
Yes?
and the exponent, that wouldn't work either, right?
No, it doesn't work. Okay, so these are the things that you need to know for these polynomial things. I think this is the new lesson only in these 2 pages, and you have some I realized when I was at your age, my teacher actually gave me a question, so that was very interesting when I saw the solution. Okay, so let me just finalize this lesson today by something like this. Let me start something. If I give you a polynomial, this is not the question I'm talking about. I just want to motivate you, okay? I can ask you in the exam in 2 different ways. Using mathematical symbols, I can ask you to calculate P of 1. What does it mean? It means replace wherever you see x with 1 and calculate. Yes, so P of 1 means 2 times 1 to the power of 2 minus 1 plus 1. If I calculate, it becomes 2. Or I can ask you, calculate the value of P of x for x equal to 1. That is the way that if I want to ask in English, I should use sentences like this. Calculate the value of P of x for x equals to 1. Okay? Or I can simply write it in mathematical language. What is P of 1? Yes? Is that understandable? So technically it is right. But the interesting question was this question. Let me write you, and I want to give you time. Without calculators, of course. Yes? When the lesson ends, do you know?
13:05.
Pardon?
13:05.
Okay, so we have time. So let me write this. P of x is 6x to the 7. Because this is important that I copy and paste everything, because otherwise it will not work probably that good. X to the power of 6, 2x to the 5, and then 5x to the 4, and minus 2x to the 3, plus 6x squared, plus x plus 1. So, do you agree that this is a polynomial?
Yes.
It's a long polynomial of degree? 7. Yes? That's a polynomial of degree 7. And I ask you to do this. Without calculator. And whenever you are done, you can just read your number for me. Of course, in principle, this question is simple. You just take every x that you see out and put 1/3 instead. It becomes a very big messy number. I want you to find the final number. I want to teach you a trick. I was very excited when I saw the trick when I was at your age. Hopefully you will get excited as well. Okay, so let me just pause the video a little bit so that to see how you will think about this problem.
So I think I found a trick.
Yes, can you just talk about that?
So, unless I'm mistaken, I think that 1/3 is equal to 3 to the power of minus 1. Is that correct?
Yes.
So you could just inverse. So basically it would be, instead of x, you could just put 3 and then instead of the exponent you could put a minus.
That's correct. So what you are saying is correct, but is it useful for this context?
I haven't come that far yet, I just figured
So
it out.
what you said is that, so you say you can write something like this for the first
Yes,
step.
exactly.
Yes, but I wouldn't say that this worked, because
Okay.
if you want to know something about this, there is only one way to write 1 over 3 to the power of 7 again.
Yeah.
Unless you have a very brilliant idea why negative powers would be in this case easier, which I don't see it. I'm ready to hear from you.
Okay, well,
Yeah.
thought I'd just say.
But do you want to hear the hint so that you can proceed at least?
Yes.
Okay. So what I want to say, I will not concentrate on putting this in all of them in one go. What should I do? Let us just concentrate on these two terms. Of course, I have to put 1 over 3 in all of them and calculate the whole bunch, but let us just focus here. Okay? If I have given you this, okay, I have to replace x with 1/3. But the trick is this. Yes?
Factorize 6x. No, factorize x times x.
Okay, so you mean that to take x to the power of 6 out, factorizing means this. Do you mean this? That is actually good.
Yeah.
Not bad. I didn't think about this. I wanted to say it in a different way, but this also works. So if you don't mind, let me just do it in this way. Here, let me just, of course that's exactly the same idea. So 6x times x to the power of 6. Do you agree with this one or not?
Yes.
If I write this equality, do you agree that this is a true equality? Yes or no?
Yes.
Okay, but how do you think I will do this? Continue.
Just factorize x.
Oh, factorizing is the same story.
Yeah.
I don't have anything against that, but I want to put x equal to 1 over 3rd. Yes?
No, I was just gonna say that x to the power of 6 plus x to the power of 6 is 2x6.
No, because what happens for this 6x here?
Right, right. Forgot.
Yes, Hussein, do you want to say something?
You're gonna do x to the power of 6 plus x to the power of 6. It's just 2x to the power of 6.
But what happens for this part then?
Then you factor.
No, you cannot add these two. If the question gets harder, if you keep silent, do you remember my proverb? Actually, I told you, if you don't know something, and you know that you don't know, is good. But I don't know why do you add these two together. You're not allowed to do that. Because I have a product here, I have an addition, multiplication addition. Which one has a priority? Multiplication, so you cannot add these two.
Yeah.
That's the good point about mathematics. If you cannot do something today, you cannot do it forever. Okay, so that's a good point. Okay, but nobody forces me to put 1/3 in all of them. I just put 1/3 for the time being only in this x. Of course, this is also 1/3. This is also 1/3. Instead of writing it down, let me just keep it in that way. What happens then?
Oh.
At the end, I want to put x equal to 1/3. But what happens to this part? It becomes 2.
Yeah.
And then 2x6 plus x6 is 3x6. Yes? So this means that this combination is 3x6, but I can use the same trick between this and that. Yes? So 6x6 plus 2x5, what can I do? 3x times x5 plus 2x5. Agree? So I wrote this one in that way. I realized this is 3x6, and then I took this one. I am supposed to add it to the next term. I wrote it here, but I used the same trick again over and over again. Instead of 3x to the 6, I wrote it in that way. Do you agree with me? And then I just copied and pasted the last one. But again, this I will take it and put 1/3. So what would we have? What's happening?
1.
It becomes 1. So it becomes 1x5 plus 2x5, which is
3x5.
3x5. And what is the next? So this has been calculated so far. So I am left with this one and that one, yes? 6. I will use the same trick. Instead of 3x to the 5, I write this. Yes? Is that understandable? And then I put 1/3 here, it becomes 1. x4 plus 5x4, it becomes 6x4. So I calculated this one as well. And then what I come here, I put 6x4 minus 2x3. The trick is the same. 6x times x3 minus 2x3, yes? Put x to the power, x is 1/3. What is the answer? This is very interesting now. What happens?
Cancel.
It becomes 0. So forget about all of this. All of them are gone. So that what is left? Only 3 terms. Because up to there, it cancelled out. Who cares about the particular value? This is the power of algebra. So I keep x, I use x, I don't need to calculate, yes? If I need at the end, if some x is left at the end, yes, I have to take it out and put 1/3 again. But no x is left to this point. And of course, I can use this trick that's the same. Can you tell me, even I don't need to bother here, even though this is so simple, I can just put the number, it is calculatable, yes, using your hand. Calculatable is the wrong word, yes?
Calculable.
Calculable, yes. So this should be what? 6x, the same story. Yes? What is 6x now?
2.
2x plus x.
No, it's 2.
It is 2, but then it becomes 2x plus x, 3x plus 1. And now this is the only x left. Remove it and put 1/3. What's the answer? 1 plus 1, 2. The answer is 2. Yes? So that was a very nice trick. I remember when I was 13 or 14, I saw this question. So I was really excited. I hope that I can see some of you are excited. Yes? So that's good. Any questions here? Do you want to give you another one to practice this idea?
Sure.
Yes, I will just I write one more to practice this idea. You know that many questions are multiple choice questions, so that was one of the... By the way, probably 2 is not possible to guess at all, because you have 1/3. If you raise it to power 7, I don't even know, it becomes 6 over that huge number. It's a fraction, a fraction, a fraction, and suddenly at the end you get 2. So it was not possible to probably guess. Okay, so what I have here, let me just write it here for you. And then I'm sure that you can solve this because you learned the trick. And then if you want to be a good problem solver in mathematics, you need to have a very big toolbox and put everything you learn in that toolbox to use it later. Of course, if you don't care, that's up to you again, but you will not be a good problem solver. So let me just give you another one. P of x is equal to x to the power of 5 minus 12x to the power of 4 plus 12x to the power of 3. And then minus 12x. I'm sure that you learned the idea and you can solve this. Solve this. Give me what is P of 11. Whoa. Without calculator, of course. So let me pause the video. Yes, let us see. I don't know if it works or not. Okay, so in Geogebra, because we want to really use this extensively this year, so here we go to another view for cast view here. So where should I? You see, I go here. This mouse is really bad. So let me just use my fingers here. If it works. So I want to get rid of this algebra. And I want to make this, yes, good. Okay, so if I want to type something here, so I want you to read that one for me. I hope that I can punch it using my, can you read it for me?
Yeah.
So what was that? It was x to the power of 5.
x5.
So let me just write x to the power of, so 5. What can I do with this one? I don't know. So x to the power of what?
x5.
5.
Minus.
Every now and then it will come up. Okay, so yes, yes. Minus. How should I put minus? So I will go here. Minus. So this is Swedish keyboard. I am not very familiar with that. Minus. Okay, and then
minus 12x4.
12x to the power of 4
plus 12x3
plus 12x to the power of
3
3, yes,
minus 12x to the power of 2.
minus 12 again,
Yeah.
x to the power of 2,
2 minus 12x minus 1.
minus, that was probably minus 12x minus 1. Is that right? So let me make it a little bit bigger so that you can see what I have typed.
Okay, here we go again.
No, I don't really want to go through this.
Can we go?
Again, please. X to the power of 5
x5
Yes.
minus 12x4
minus 12x4
plus 12x3
plus 12x to the power of 3
minus 12x squared
minus 12x squared
minus 12x
minus 12x
minus 1.
minus 1. Okay?
Yes.
So I was reading a little bit. This option is what you want. You
Okay.
want to substitute a value in a polynomial or anything. Okay? So when you press this one, this opens. So x, what I want to punch instead, what is that? 11. I'm supposed to put 11 instead of x.
Yeah.
And then I say okay. So it replaced every x with 11. And then I go here, probably, I don't know, it copies. And then I put equality. Minus 254 is the answer.
Okay.
Yes.
So I want you to learn this feature in Geogebra. Typing is no problem. You type it, and then this feature 7 in that box that you see up there is the one that you want to use to substitute. So these things you need to learn. And the good point about this book is every now and then there are examples using Geogebra. Of course, Geogebra there is in Swedish, Geogebra mine is in English. Okay, so that would be minus 254. Okay, I just want to make sure that this is a test actually, because now the recording application is down there. So I want to see if this is being recorded. Otherwise, I have to cut it and upload it on the YouTube. Okay, now I will pause the video. Okay, now that we saw it on Geogebra, what should I do? Instead of, so I will start with 2 terms. Of course, I also have other terms. So what was the rule? What was the idea? Instead of x5, what should I write? I write x times x to the 4, agree? And then minus 12x to the 4. But this one is how much? All of these x's are 11, but I'm not in hurry. I just replace this one for the time being by 11. And then 11x to the 4 minus 12x to the 4 is simple. What is that? Minus x to the 4. Agree? I have minus x to the 4 with the next term. So minus x to the 4 plus 12x to the power of 3. Yes? What can I write here? I can write minus x times x to the 3 plus 12x to the 3.
Yeah.
But again, I replace this x with 11. What is left for me?
Minus 11x.
Minus 11x cubed plus 12x cubed, which is 1x cubed. Yes? And then I will take this x cubed to the next one. So x cubed minus 12x squared. This becomes x times x squared minus 12x squared. But this one is 11.
11x minus.
So it is minus x squared. Agree?
Yes.
And then I will have minus x squared with the next one.
Just minus x.
So this becomes minus x times x minus 12x. Instead of x I put 11, so it becomes minus 23x. So it would be minus 23x minus 1. So I just got rid of all those and I got this one. So what I need to do is just to write this multiplied by 11 minus 1. So let us do that. 11 times that is what?
253.
253. So minus 253 minus 1 is minus 254, as we saw in Geogebra. Yes? So we had 2 birds with 1 stone. So we just learned this nice trick. We also learned how to use Geogebra to solve these kinds of problems. The reason that you need to know Geogebra is because you yourself want to discover something. So this is hard. You want to see, is your idea correct or not, so you can check it using Geogebra. It's very important and handy tool. Okay? No questions? Yes, we end the lesson here. Thank you very much. there would be a set of exercises. I will publish which pages to read. There is only 1 or 2 pages in the book and 2 sets of exercises. I will also upload the detailed solution manual. All right.